Alright everyone, now that we know how logistic regression works and we know how this is going to work with the three species we have, it's time to apply it in the iris dataset. So let's import it first. So from sklearn.linear model, we're going to import logistic regression. Now let's create a variable called logreg, for example. Then we can just run this function called logistic regression. And now let's do logreg.fit. And we are going to use x train and y train. Now let's try to make a prediction using this model. So let's just print something here. So logreg.predict. Okay, so inside here, we need to pass a list of observations. So this is going to be the list of observations, and each observation itself is a list. So we can just do this and pass the measurements for an observation inside here. Let's go up and let's pick one. I'll just pick one that I know that it's species number 2. So let's get this one, for instance. Let's adjust this real quick. All right. Let's run this and let's see the prediction made by the computer. Pretty cool. So the computer is telling us that these measurements are probably for a, let's see, species number 2. Let's remember, we are talking about Virginica. So the computer is telling us that if we have a new observation with these measurements, it's predicting that it's a Virginica. And we know that this is correct. The computer just used the logistic regression model to come up with this prediction. So in the previous lesson, I showed you how the one versus all method works. And now there's something cool we can do, that is, instead of printing the prediction itself, we can print something called predict proba. If we run this, what we have here are some probabilities. So this means that after training with all that data, the computer is doing the one versus all method. So this first number is the probability of it being setosa. The second number is the probability of being versicolor. And the third one is the probability of being virginica. So this one is 0.09, I think that's it. This one is 18%, and this one is 81.7%. So here the computer has no doubt that this observation is a virginica. So this is really cool to help us understand how the computer is making the prediction. Okay, so now instead of printing one prediction, let's test the performance of our model. So let's create a new variable called predictions. This time let's use predictions logreg. So logreg.predict. Then we are going to use the x test to make the predictions. So we already used the x train to train the computer. And now we are going to make predictions using the other group, which is the x test. Now we can create another variable called performance logreg. And now we are going to use the metrics again. So metrics dot accuracy score. And now we are going to compare the y-test, which are the actual answers, with the predictions made by the computer. So let's print performance log reg and see what we got. And now we can see that we have 96.6% accuracy by using the logistic regression in our dataset. So for this case, it's probably better to use KNN with a value around 15, for example, but we can play around with it. So here, where we're doing the split, let's use a test size of 25 again. And let's pick a different random state now. Let's say 20. It doesn't matter. All that matters is that once you pick a number, you use the same number for both models. So let's use 20 now. So now let's run everything again. And now we have something a bit different. As you can see, this time we don't have 100% with the K and N, but we have a lot of good K values that are, if we look at the data, they are 97.37% accuracy. So again, around 15 would be the best choice for the K value. Now let's continue to run this and see how do we go with the logistic regression. I'm going to run this cell again, and this time we had 92%. So you can keep testing to make sure you're going to pick the best model. So in this case, it seems that using KNN with a value for K of 15 is probably what's going to have the best performance. So that's it for this video. I hope you like machine learning with Python, and I'll see you soon.